Welcome back, everybody. We're going to work on polynomials today, starting with exponent rules. So exponent rules are shortcuts to help us simplify like terms with exponents. So this right here is supposed to be a multiplication in that box. And basically the product rule says if you're multiplying like bases, you can add the exponents. So if I have 2 to the second times 2 to the third, really what that means is you have 2 times 2 for 2 to the second, and then 2 times 2 times 2 for 2 to the third, and you're multiplying all that together. Well, how many 2's do you have? You have 1, 2, 3, 4, 5. So that would be 2 to the fifth. Well, we can shortcut that by saying 2 plus 3 is 5. Power rule. So if I have something that has an exponent to another exponent, I can find the answer by doing the two exponents next to each other. So raising a power to a power, we multiply the exponents. 4 to the fifth to the third. Well, that means we have 4 to the fifth 3 times. 4 to the fifth times 4 to the fifth times 4 to the fifth. Well, from the product rule we just learned, that would be 5 plus 5 plus 5. Or we could say instead, well, what is 5 times 3? 5 times 3 is 15. 5 plus 5 plus 5 is 15. So either way, we get to 4 to the 15th. It's just a shortcut to help us with getting to that simplified version a little bit quicker. Power rule number 2. If I have two different terms inside a parenthesis with an exponent on the outside, that exponent applies to both of them. 7x to the third means 7x times 7x times 7x. So if we did like terms, we have 7 times 7 times 7, and x times x times x. That's 7 to the third and x to the third, which basically we kind of, for lack of a better phrasing, distributed that 3 exponent to both terms. Over here, we raise each factor or term to that power. Power rule number 3 says if I have two things that we are dividing, two terms or factors, then again, kind of like we just said, that exponent goes to both. And this is the understood that the bottom cannot be equal to 0. So 3/5 to the fourth power is the same as saying 3/5 times 3/5 times 3/5 times 3/5. That's 4 3s and 4 5s. So 3 to the fourth over 5 to the fourth. So we are raising the numerator and the denominator to that power. Some practice on that. We have y to the fourth times y to the seventh. That means we can do y to the 4 plus 7, which is y to the 11th. For letter B, product rule, we're going to multiply like terms. 6 times 9 times 2, and then z, 5 plus 3 plus 2. Again, we're adding because this is a product. We're multiplying there. We're using the product rule. 6 times 9 times 2 is 108. Z to the 5 plus 3 plus 2 is 10. So 108 z to the 10th power. Power rules. 5 to the third to the second means we can do 5 to the 3 times 2 which is 5 to the 6th. 3 to the 4th, and x to the 12th. We're going to start with the fact that we know that that third power on the outside gets applied to both terms or factors on the inside. Then we use this power rule that we just did for example A and say, I know when I have two exponents like this, then we multiply. So 4 times 3 is 12, and 2 times 3 is 6. So 3 to the 12th, x to the 6th. And that's where we'll stop with that one. For letter C, we're going to do the same thing we just did with B. We know that this third power will be applied to both the numerator and the denominator. And then using the power rule number 1 that we did for A, we do 2 to the 5 times 3 power and B to the 4 times 3 power. 5 times 3 is 15, and 4 times 3 is 12. So 2 to the 15th over B to the 12th. Letter D gets much more interesting. So this 5 out here is supposed to be an exponent. Kind of hard to see that it actually is one. Maybe if it were way up here, it'd be a little easier to see. So that means that that fifth power goes to the negative 2. It goes to the m to the 6th. It goes to the t to the 6th. And it goes to the z. Now remember, if there's no exponent, there's always a 1 there. And so z to the 1st to the 5th. Negative 2 to the 5th, I can do that. It's not a super huge number. That's actually negative 32. Product rule here, just like letter A, 6 times 5 is 30. For t, 6 times 5 is 30. And then for z to the 1st times 5, 1 times 5 is 5. And so this would be our simplified answer. The last part we're going to discuss today is the zero exponent rule. Anything that is a non-zero real number to the 0 power is 1. Any non-zero number with a 0 exponent is 1. Now be careful, because they will try to trick you a little bit. And you'll notice in these examples we have some parentheses going on. So we'll start with example A. We have 4 to the 0, which is 1. Negative 4 to the 0. Now the negative is inside. So again, if you did that in your calculator with the parenthesis around the negative 4 caret 0 power, you're still going to get 1. For letter C, remember that negative is really a negative 1. Times 4 to the 0 power. So you do 4 to the 0 power first, which is 1, and then negative 1 times 1 is negative 1. So that answer would be negative 1. Same thing with letter D. You cannot add the opposite here and make that just a positive 4 to the 0 power. That's a negative 1 with a negative 4 to the 0 power. Now we know from letter B here that negative 4 to the 0 power is 1. And then this negative 1 on the outside, negative 1 times 1 is negative 1. Remember, this whole thing in here, it's not going to matter what's in there, because as long as it's all inside the parenthesis, the 0 power applies to all of it, and that will be 1. This is where we are going to stop for today. Thanks so much for joining. We'll see you next time.